Hi guys, today we're talking about the power rule, and in calculus we use this to find the derivative of various functions. So you've got two basic parts to this power rule. You've got d over dx, and that's just notation for saying the derivative of something. So you've got the derivative of a constant, which is c, is always going to equal 0. So for questions 1 and 2, you can see that these are both constants, meaning they don't have an associated x value. So for both of these, they're going to equal 0. Okay. So for the second part, we've got the derivative of a function is going to equal the exponent, which is this n, minus 1. But first thing you're going to do is you're going to take this n, alright, you're going to multiply it by whatever is in front of that x. So if it's a 2x squared, you're going to take the 2 from the exponent, you're going to multiply it by the 2x, which will leave you with a 4x, right? And then you're just going to take that 2 for your exponent minus 1. It's going to leave you with 1. Alright, so for number 3, we got 2 minus 2 over 3x. Alright, so this is going to be pretty simple. We know that the derivative of a constant is 0, and we're going to take the exponent of this 1, so you can imagine there being a little 1 up here. 1 times 2/3 is going to leave us with 2/3, and because we subtract 1, so 1 minus 1 is going to give us 0, and anytime you have x to the 0 power, it's just going to equal 1. Okay, so we're losing our x right there. Alright, so the derivative of this function is just going to be this negative 2/3. Alright, for number 4, we've got 3 over 4x to the 8th power. So we take this 8 and we multiply it by 3/4. Alright, so 8 times 3 will give us 24, divided by 4 is going to leave us with 6. So we've got 6x, and since so for this n minus 1 part, we've got n, which is 8, right? We're going to subtract it by 1, and it's going to leave us with 7. Okay. Alright, so for number 5, we've got x to the 3rd power minus 4x plus 6. Alright, so what do? We take this 3 times the front, so we get 3x. We're going to drop our exponent down, because 3 minus 1 is 2. And then we've got this x to the first exponent power, so we get 1 times 4. And remember, since this so we've got, let's see here, so say you've got x to the 1 power. When you drop it down, you're going to subtract it, which will then give you x to the 0 power, which equals 1. So pretty much when you do that, you are eliminating that x. Okay. Alright, so and then plus 6, and when you find the derivative of a constant, which in this case 6 is a constant, we're going to be left with 0. So the answer for this, the derivative of this function, is just going to be 3x squared minus 4. Alright, so for number, what are we on? 6. Alright, so this is going to be a little bit new. We've got the square root of x minus x. So what do? Well, we've got to rewrite it. Alright, and we say x to the 1/2 power minus x. Okay, so the square root of x is obviously all we have done so far is we've just rewritten it. Okay, so now we take this x to the 1/2 power and we multiply it by the front, right? So now you're going to get a 1/2 x, and what's going to happen to the exponent right here? Well, we take, so for this 1/2, we take this 1/2 minus 1, because it's n minus 1. And of course you can't just say minus 1, because we don't have a common denominator. So we say 2 over 2. And as you know, 2 over 2 is the same thing as saying 1. Alright, so 1/2, or 1 minus 2, is going to give us with a negative 1/2, okay? Or you can just say 1/2 minus 1 equals a negative 1/2, alright? So this exponent is going to be left to the negative 1/2 power, alright, minus what? 1. Because you take the 1 up here and you multiply it down, which leaves us with the 1, and then this original 1, you know, turns to 0. Same thing with up here. 1 minus 1 equals 0, which equals 1. So you're just left with 1, okay? Alright, so that is the derivative, but most teachers don't like to have a negative exponent in the top. So what we're going to do is we're going to rewrite it, and we are going to say 1 over 2x to the 1/2 power minus 1. Alright, and you can also rewrite it again if you want to. That is the same thing as saying 1 divided by 2 times the square root of x, because x to the 1/2 is the square root of x, minus 1. Okay, so that, and this is probably the most preferable form your teacher would like for that kind of problem. Okay, so on to number 7. We've got a 1/2 x, and before I do that real fast, let me just show you something, just to kind of refresh your memory. Anytime you've got, let's say, x to the, let's just say negative 5 power, you can rewrite that to say 1 over x to the 5th power, okay? So these both mean the same thing. You're just taking this negative exponent and we are dropping it down here. Alright, so for number 7, we've got 1/2 x to the 6th power minus 3x to the 4th power plus x. Alright, so we take the 6 times the 1/2. Okay, here we go. We get 3x. 6 minus 1 is 5, so drops down to the 5th power, minus 4 times 3, which is 12x, and then we drop the exponent again, so we're left with 3 plus 1. And that's how you solve that one. It's pretty easy stuff. Okay, so going on to number 8, we've got 2x to the negative 3/4 power. So same thing, we're going to take this negative 3/4 and we're going to multiply it by 2, which gives us a negative 6 over 4, which then can be factored down to negative 3 over 2. Alright, so for this first part we say negative 3 over 2 x. Now for this part, the fun part, here, for the exponent we've got to subtract it by 1, so we've got a negative 3 over 4, right, minus 4 over 4, and 4 over 4 is the same thing as saying 1, right, so you get a negative 7/4, right, so this exponent is going to be a negative 7/4. So let's rewrite that so it looks pretty. So we have a negative 3 over 2x to the negative 7/4 power. So what you're going to be doing here is you just rewrite this and you say negative 3 divided by 2x, because 3 has x, right, to the 7/4 power. Okay. Remember, when you drop that down, you can get rid of that negative sign. Alright. So for number 9, we've got negative 12 over s to the 5th. Well, first thing you're going to do is you're going to rewrite this to say negative 12 times s to the negative 5th. Because remember over here, if you have, so we have this x to the 5th, it's the same thing as putting an x to the negative 5th power up here up top. Okay, so then we take this negative 5 times the negative 12 and we get a 60 s to the negative 6th power. So you might be tempted to add 1 and make it, or you might say 5 minus 1 is 4 or whatever. You have to remember this negative 5 minus 1, okay? So you're going to be left with a negative 6. And then you can, of course, rewrite that to say 60 over s to the 6th power, okay? And of course, let's see here. The thing that we have to just always check your negative signs because it's real easy to forget that. So we start off with a negative. Oh, that turned to a positive. That's right. Okay. Okay, so we are good. All right. So that's how you write that one. And then for number 10, we've got an x to the 5/3 power minus an x to the 2/3 power. And so we get 5/3 x, and then of course we're going to take this 5 over 3 minus a 3 over 3. It's going to leave us with a 2/3. Alright, so 5 over 3x to the 2/3 power, alright, minus a 2/3 x to the what? So 2 over 3 minus 3 over 3 is going to leave us with a negative 1 over 3. So a negative 1 over 3. And to rewrite that so we don't have a negative in our exponent, we say 5 5/3 x to the 2/3 power minus 2/3 x to the 1/3 power. Alright? And that is how you solve that one. Alright, I hope that helped.